Hey guys, welcome back everybody. So what we have covered, let me recap you. So basically we have seen the difference between the layer 2 and layer 3 loop, right? We have seen the what is layer 2 loop, right? And then we have seen that what is layer 3 loop, right? Then we have covered that how to prevent layer 3 and layer 2 loop. So in a layer 3, we have a protocol is known as a sorry, in a layer 3, we have a TTL field, and based on the TTL field, we are preventing the loop on the layer 3 network. But if I talk about in the layer 2, right, in the layer 2, we have a spanning tree protocol. So basically, the spanning tree protocol is used to prevent the loop. We don't have a TTL concept in our layer 2 header. And that's why uh, in early 90s, 80s, right? So there's a girl, Radia Pellman. So this, she introduced the spanning tree protocol to prevent the loop on the layer 2 network, right? So spanning tree protocol has categorized in the multiple ways. One we call as a CST protocol. It's known as a common spanning tree protocol. Another is called as a PBST protocol. That's known as a per VLAN spanning tree protocol, right? And then we have a RPBST protocol. So in our Cisco, we call as a RPBST protocol, right? And on a IEEE standard, we call as a RSTP protocol, right? So in the IEEE standard, we call as RSTP, and then in a Cisco, we call as a RPBST. Then we have a MSTP protocol. So if you guys remember that, right? Right? If you guys remember that in this CST protocol, what happened? It was represent a common spanning tree protocol. Common spanning tree protocol means what? For all the VLAN, right? For all the VLAN, we have a single root bridge. All the VLAN. So if you have a 100 VLANs, for the 100 VLAN, you will have a 100, sorry, one root bridge. That's the only one thing, right? But in the PBST case, what happened? In the per VLAN spanning tree protocol, you do have ability. You can see that it's a per VLAN spanning tree protocol. In this case, what happened? We have a, for each VLAN, right? We have a separate, we can have, right? Not we have, we can have, right? Separate root bridge. So if you want, you can do that, right? You need to change the priority. So if you have 100 VLANs, right? Take example, then you will have 100 root bridge over there. Based on the manipulation, you can do that, right? Same concept will be over here in the RPVST protocol. So only the name we change is same like a spanning tree protocol, right? It's called as a rapid, right? Spanning tree protocol. Only the difference if I talk about the PBST protocol is what? The PBST protocol is a slow protocol, right? And this is the fast protocol. That's a major difference in that. One more thing about the common spanning tree protocol, what happened? In a common spanning tree protocol, you cannot achieve the layer 2 load balancing. It's not possible to get the layer 2 load balancing in the CST protocol. No layer 2 load balancing is possible in the CST protocol. Where if I talk about the PVST, right? In the PVST protocol, what happened? I can do have ability to achieve the layer 2 load balancing. If you guys remember that, we have seen this concept. Then after that, we have seen that like how to manipulate the cost, how to manipulate the root bridge, right? We have seen the election of the port. We have seen the election of the port, root port, DP port. Then we have seen the blocking port. Then we have also seen that the what we call is spanning tree states, like a disable state we have. Then we have a blocking state, right? For the few millisecond, the port will went to the blocking state. Then it will has a listening, right? In the listening, it will spend the 15 second. Then we have a learning 15 second. Then now forwarding, we have a in a forwarding state. What happened now? You can send all the data traffic, right? So these things we have seen. Then, if you guys remember that, we have also covered the spanning tree security, right? STP security, we can call it. So in STP security, we have seen that what we call, we have seen the port fast concept, right? The port fast, then we have seen that BPD guard, then we have seen that BPD filter, right? Then we have seen that what we call root guard. Then we have covered the loop guard, right? These things we have covered in spanning tree security. If you guys also remember that, right, we have also covered the TCN BPD, right? So topology change notification. So what happened if you have something failure in the layer 2 network? Then after that, we have also seen the configuration BPD, right? And apart from this thing, to improve the convergence, right? To improve the convergence of the layer 2 network, or we can say that not layer 2 network, to improve the convergence, right, of layer 2 spanning tree protocol, layer 2 is PBST protocol, right? We have seen the port fast mechanism, right, for the insignificant topology change. Then we have seen that uplink fast feature, right, for the direct link failure, and we have seen that backbone fast feature, right, for the indirect link failure. So if you see one thing, try to understand this concept, right? To make a faster, right, to make a faster, right, to make a faster of the PBST protocol, you need to add a extra configuration. You need to add a extra configuration. Let me recap. So if you remember that we have a topology, something like that, we have a switch 1, right? We have a switch 2, we have a switch 3, right? So normally, if you guys remember that we have this is the DP port, this is the DP port, this is the RP, and this is the RP, and the DP, and this is the blocking, because this is my root bridge, right? After that, we have a users behind this guy, switch 2, and we have a users behind the PC3. Let's talk about the user perspective first of all. If you remember that this port 0/2, right? If I'm gonna connect the any PC, if I'm gonna connect the any PC to this particular port 0/2, normally what happened? This is my access port, right? On the access port, also a spanning tree protocol is enabled, because by default, a spanning tree protocol is enabled on the access port, right? Or trunk port as well. So simply we can call as a spanning tree protocol is by default enabled on a all switch port interface. On a all switch port interface, spanning tree protocol is enabled. Simple language. So take example, if the spanning tree protocol is enabled on the 0/2, what happened? Normally this interface will go through the blocking, listening, learning, then forwarding. So it will take a 30-second. So till 30 second means what? 30,000 millisecond. Can you imagine that? In a 30-second, we have a 30,000 millisecond. So when now you are like, you're becoming a pro, right, in the networking. So always don't consider the second. Consider always in the millisecond. The reason I'll tell you, because your packet, right, you are sending the packet in the bits per second, right? So you have to look for how many packets you are sending in the millisecond, because it is a recommendation to have a minimum 150 millisecond delay is suffer, right? So take example, if you have a voice traffic in your network, so voice traffic can only face the 150 millisecond delay. If they are facing the delay beyond the 150 millisecond, right? Take example, if you have a voice traffic in your network, and if they are facing the delay beyond the 150 millisecond, then you have a packet loss in a voice. Then you have a drop in the voice. Then you will not hear the properly. Sometimes what happens when you make a call to somebody, right? And due to the due to the bad internet, you are not able to listen properly. Some packet will be lost in between, right? So that's happening because of the delay. So in a 1 second, you have a 1000 millisecond. And can you imagine that it's just a 150 millisecond is a recommendation? If there is a delay beyond the 150 millisecond, you will have a loss. So understand this concept. If this PC will connect this port 0/2, it will take a 30-second, right? After the 30-second, now the PC can send and receive the data. So to improve this convergence, I can implement the feature over there. It's called as a port fast. Right? With the help of port fast, what happened? Two things will happen. First of all, it will skip the listening and learning state. And second thing is what? It will never generate the TC and BPD. If this link goes down and up, it will never generate the TC and BPD to the root bridge. Never. First thing, right? So we have done with the port fast. Second thing, if you remember that in the direct link failure, for example, if this link goes down, take example, if this link goes down, so this interface, the blocking port will take a 30-second. This blocking port will take the 30-second to put this port in the forwarding state. If this link goes down, the blocking port will take a 30-second to put this port in the forwarding state. So again, what happened? To avoid this problem, we can implement the uplink fast feature. Again, you need to do the extra configuration, right? Again, you need to do the extra configuration over here. We need to implement the uplink fast feature. Then take example, what happened if this link goes down? If this link goes down, then this link, right, the blocking port will take the 50-second to put this port into the forwarding state. It means that if something is happening in the indirect link failure, right, then what happened? We need to take the 50-second to put this port into the forwarding state. So normally to avoid this problem, what we can do that we can implement the backbone fast feature, backbone fast feature, and backbone fast feature on every switches. But still, see, try to understand, even implementing all this feature, right? Even implementing all this feature on my PVST protocol, even implementing all this feature in the PVST protocol, still I'm facing some delay. Still I'm facing some delay. Can you imagine that if I'm going to implement the backbone fast, still I need to wait for what, 30 seconds? Still I need to wait for what, 30 seconds? If I'm implementing the uplink fast, if still I have to wait for the like almost 2 to 1 second, almost 2 to 1 second. It means that 2000 millisecond, up to the 2000 millisecond I have to wait. After guys, please pay attention. It's a very important topic to understand the next protocol. You have to still wait for the up to 2000 millisecond. See, in a up to 2000 millisecond, can you imagine that if you have a voice traffic in this network, you will lose almost 10 packets. Almost 10 packets, you are going to lose it. Forget this features, forget this feature right now. Take example, if right, what happened if I'm not going to implement this feature? This link will take a 30 second, this link will take a 30 second, this link will take 30 second to make a convergence in the network. So either you're going to apply this feature, right? Still you have to wait for the some time to converge the network. And the bad part, right? The bad part of this what? The port fast, uplink fast, backbone fast, these all features are a Cisco proprietary. So you cannot run on any other vendor. That's a first disadvantage. Second disadvantage is what? Second disadvantage is you need to put the extra configuration. See, I'm not telling it's a bad thing. Normally, right? Normally we do this thing, right? Normally we do this thing to get the more flexibility, to get the more features. We are putting the extra configuration. That's not a bad thing. But think about it. If you're going to put the extra configuration, then what happened? Your CPU will be high. Your CPU will be high. You need a memory consumption as well as for the configuration perspective. Third thing is what? If I'm going to put the extra configuration, you need an extra maintenance for that one. You need an extra maintenance for that. And you need to first clear out this thing. Okay, on which switches you're going to implement the backbone fast and uplink fast feature. You need to all those things you need to take care about it. Okay, here I need to implement the uplink fast, and on all the network I have to implement the backbone fast. Okay, here I have to implement the port fast feature. So if I'm going to implement the port fast feature, I need to also implement the BPD guard and BPD filter. So if you see the PVST protocol, right, eventually, if you see the PVST protocol, it's good. In the 90s time, when the PVST protocol comes in the picture, it was awesome. Right? Because on that time, in the 90s time, we don't have a such amount of traffic on the internet. Right now, we have all those things. We have a Skype, WhatsApp, Facebook, YouTube, right? Shorts, Instagram Shorts, everything is coming. Right now, can you see that all these traffics are coming? We have a huge traffic. Remember in the 2008 and 2006 time, we have just the Orkut, we had a simple Orkut, right? In the 90s time, have anybody seen the internet? I remember myself, right? I have seen the first YouTube in the, I think so, 2008 or 7. Like on the time I've seen, the first time I have seen the YouTube, people was no idea about the YouTube. Right now, like even your mom and dad, my mom and dad are using the YouTube. So the traffic of right now is a very huge. So in the 90s time, the PVST protocol was fantastic. It was doing the great job. Right? Even if the 30-second delay is fine in the 90s time, right? In the 90s time, I don't have the issue of the 30-second. That's fine. 20-second, 50-second, that's fine. But nowadays, no, nowadays we need a faster. Because just imagine, just for the 2 minutes, or maybe not forget the 2 minutes, just for the 10 and 20 second, if you're getting a buffer on the YouTube, or if you're watching the movie on the Netflix, and just for the 10 seconds, if your internet get flat, then what happened? You're worried, okay, what happened to the internet? So, have I done the recharge or not? Is there any problem with the internet right now? All the questions comes in your mind. So for nowadays, for this era requirement, the PVST protocol is not suitable. And that's why we came with the solution is called what? We came with the solution is called rapid PVST protocol. So in the PBST, I just added this word rapid. Rapid means what? If you just go to the synonyms, it's a fast. Rapid means what? It's a fast. How the rapid PBSTs are different from the PBST protocol. How this guys is going to make this guys a faster. How the rapid PBST make itself as a faster protocol. So for this thing, you need to understand the some basic concept of the configuration BPDU, and you need to understand the states of the configuration BPDU. So let's understand the difference, and then you will eventually you will understand why the RPBST is a faster protocol. So let's take example. Normally in the PBST protocol, what happened? If you remember that. Normally in the PBST protocol, right? In a PBST protocol, we had a disable state, right? Understand the concept right now. We have a blocking state, right? What we have now? We have listening state, we have a learning state, right? And we have a forwarding state. These are the states we had in the PBST protocol. Now, if I talk about the RPBST protocol, right? In a Cisco, we call as a RPBST. In a IEEE standard, we call as a RSTP protocol. So in a RPBST protocol, what happened? We don't have a disable state, because in the disable state, we are doing nothing. Disable means what? You are not running with the spanning tree protocol. It means that your interface is down, admin down. So for example, let me recap this part. So switch 1 right now and switch 2 we have. So as I mentioned that on all the switch port interface, my spanning tree protocol is enabled, right? So if the interface is down, it means that it's a disabled state, right? When I'm going to up this interface, then what happened? Eventually my interface will move in the blocking state just for the millisecond. So understand this concept in the disabled state. Am I learning the MAC? No. Am I sending the data traffic? No. So I'm nothing doing. So in a RPBST, we call as a discarding state. Again, in the blocking, are we doing any kind of learning the MAC or sending the data traffic? No. Again, we can convert in the discarding state. In a listening as well as, remember, have we done any kind of MAC learning or data traffic? No, we are nothing doing in the listening state as well. Listening, we are just doing the port election, RP and DP. Just remind, we are just doing the port election in the listening state. So again, what happened? This will be converted as a discarding. In the learning, we are doing the keep learning, because in a learning state, what happened? We are going to learn the MAC address. And in the forwarding, we are going to forward the data traffic. So if you think according to the operational point of view, right? If you think according to the operational point of view, right? Operational means what? Operational means the way he is work, right? The way the protocol is going to work. In the operational point of view, in the discarding state, right? If you see the disable state, are we doing any kind of MAC learning? No MAC learning, right? And no data traffic, right? Even in the blocking, we are not doing anything, right? No MAC learning, no data traffic. Even in the listening, I'm doing no MAC learning and no data traffic. In this learning state, what happened? We are doing the MAC learning, and here we are doing the MAC learning plus data traffic. So that's why, right, what RPBST did, they converted, right? They converted all these three states into the single state. Because in this, eventually, according to the operational point of view, right? According to the operational point of view, we are not doing anything in the disable blocking listing. So they converted into the single state. So basically in the RPBST, we just have a three state. We just have a three state in the RPBST protocol. We just have a discarding, right? We just have a learning, and we just have a forwarding. Because if you see, I'm not doing the MAC learning, not the data traffic in the disable state. I'm not doing the MAC learning, no data traffic. I'm not doing the MAC learning, no data traffic. So what is the need of these three states then? So they converted this three state into the single state. That's called the discarding state. And then learning will be learning and forwarding will be still forwarding. So they change in the PBST to RPBST. Next part, what they change it. if you see, let me show you this thing in the Wireshark. PBST protocol, cloud SAR. One. Seriously. Yeah. If you see this protocol, we have a configuration BPDU. In this configuration BPDU, if you see that, we have a, this is the configuration BPDU, right? BPDU tab is a configuration. If you see the BPDU flag right now, guys, please pay attention. If you see the BPDU flag, this BPDU, the size of this BPDU flag is what? The size of this BPDU flag is a 8-bit. The size of this BPDU flag is what? It's a 8-bit. This is the PBST protocol configuration BPDU. Right? The size of this flag is what? The size of this flag is a 8-bit. You can see that this flag? The size of this flag is a 8-bit. In this 8-bit, if you have a look, right? In this 8-bit, so we have a 0, 1, 2, 3, 4, 5, 6, 7. Total 8 is there, right? This 0-bit is represent that we have a topology change. TC bit, right? And this 7-bit is represent that topology change acknowledgement. So only this 2 bits we are using it. Only this 2-bit will be on, and remaining all will be what? 0, 0, 0, 0, 0, 0. It means that all the 6 bits we have, it's reserved. We are not utilizing this bit in the PBST protocol. There is no use case this bits in the PBST protocol. What RSTP did? RSTP convert this one. If you look the RSTP BPDU, let me show you that. Spanning tree protocol. And we have, can you see that the BPDU type is a RPBST now, right? And now if you see the BPDU flag, you can see all I'm gonna use it. Right? Can you see the difference now? So here we have the protocol is a RPBST, the BPDU type, right? And then we have a flag now. We have the 8-bit flag. So in this 8-bit, what happened? Again, we have 0, 1, 2, 3, 4, 5, 6, 7. 8 bits we have. Same, the 0 is going to represent the topology change, right? That's we have over here, right? This is going to represent the topology change acknowledgement, TC acknowledgement. That's a 7-bit number, right? That's this guy. And then after that, what happened? This bit was totally reserved in the PBST protocol. Now we are going to utilize all the bit. The first bit is going to represent that as a proposal. This is just a name. I'll explain you what is the use of that bit. Don't worry about that. Then we have an agreement, this flag. Again, you don't need to remember these things, right? Nobody will ask you in the interview, okay, what is the, like BPDU flags are there? Okay, nobody will ask you. You just need to understand the concept right now, how the PBST is different than the RPBST. So we have a agreement, right? That's agreement flag. Then after that, we have a, this is the forwarding state we have. Then we have a learning state. Someone mic is on, guys. Then learning state, then this 2-1 is going to represent that it's a port role. So the 2-bit, in the 2-bit, how many value you will get that? In the 2-bit, you will get the 4 values, right? So if you see, we have a 0, 0, 0, 1, 1, 0, and 1, 1. So this is 0, 0 unknown, or we can say that's a reserve. 0, 1 is going to represent that's an alternate backup port, right? Then this is the port is going to replace the RP port, and this is the DP port. So can you see that all the bits I'm utilizing in the PBST, rapid PBST protocol? All bits. So our PBST, sorry, PBST protocol has lots of disadvantage. First of all, they have a multiple states. Again, 90s time they did this, that was fine, man. But lately, what happened? Gradually, they made some changes, and after that, we found that okay, the RPVST is faster than, because we need to use these bits now. So they have used this bit into the RPVST protocol, and these bits are gonna make the PVST RPVST as a faster protocol. So normally, what happened? Understand this concept, how the RPVST is gonna work. Take example, we have a switch one, right? We have a switch two, we have a switch three. Before I'm going to explain this part, let me tell you one thing. So in RPVST protocol, what happened? We have two types of port. One, we have a H port. H port is simply going to represent that access port. Name suggests that, right? And non-H port. Non-H port means what? It's a trunk port, right? So the RPVST election will happen on this port. So right now, all these ports, right, that you can see that these all are the non-H ports. The 0/0, 0/0, 0/1, these all are my non-H ports, 0/0. Take example, the priority will be same again, 32768 plus VLAN number. So I'm not gonna write the priority, I'm just gonna write the MAC address A, the MAC address B, and MAC address C. Okay, right now all the ports are down. Right now all the ports are off. Take example, I'm gonna just turn on the link. So take example, if this link comes first, take example, what happened? If the switch A link come first and then switch B link come first, then what happened? Switch A will send the BPD packet, the configuration BPD packet. In this configuration BPD packet, what happened? They will just on the proposal bit. He will say, hey, listen, I'm gonna proposing you, right? I'm gonna proposing you, I would like to become the root bridge. When the switch B or switch 2 will receive this proposal, right? When the switch B receive the proposal flag, or because in the configuration BPD with the proposal bit on, what switch will do that? Proposal, right? The name suggests that proposal means what? I'm proposing you. That's my proposal to you, right? So what switch 2 will do that? When the switch 2 will receive the proposal bit, right? They will compare the, because in this one proposal flag, what have in the proposal BPD, we have a MAC address, or because the bridge ID as well, right? Of the switch A. So when the switch 2 will receive that A has a lower MAC address, or we can say that A has a lower bridge ID, what happened? The switch B will put this port into the root port, or all the non-H port, I'm again repeating, all the non-H port will go in the blocking state, or we can call it the discarding state, to just avoid the loop. So in a RPVST protocol, what happened? If the election, listen to me, in a RPVST protocol, what happened? If the election is going on the this particular segment, if the election is going on this particular segment, the remaining segment, right, whatever the remaining segment you have, all the non-H port will go in the blocking state, just to avoid the loop. Just to avoid the loop, all the non-H port will go in the blocking state. So once the switch 1 will send a proposal flag to the switch 2 will receive it and say that, okay, switch 1 has a lower bridge ID, that is A. I will convert this port into the RP, and they will send the agreement flag. This one, they will just turn on this bit. One, they will just turn on the agreement. Now what happened? When the switch 1 will receive it, they will convert this port into the forwarding state now. So switch 1 is the root bridge. Now after that, what happened? After that, now he's going to make an election of this particular segment. Now the switch 2 will send the same flag. Switch C, hey, he will inform to the switch C, hey, The switch A is a root bridge by sending the proposal, and we will put the A MAC address. That's the switch 1 because switch 1 is a root bridge. Switch 3, right, will receive it. If they have any non-edge port, they will put that port in the blocking state. If they don't have, then they will send an agreement flag, and they will convert this port into the RP, and they will receive the agreement, and they will change this port into the DP. So the basic funda is what? The basic funda is called as a proposal and agreement. So the proposal will send by the home. The proposal will send by to have a higher switch, right? Agreement means what? I will agree to that. You have a good bridge ID based on this. And all this process, can you imagine that? All this process, right, is going to happen in just a millisecond. I'm not talking about the second even. I'm not even saying the second. In as 1 second, we have a 1000 millisecond, right? In a 1 second, we have a 1000 millisecond. All this process is going to happen in the second. Let me show you this thing. This one. Right, so we have already discussed this BPD, right? Flag of the RPBST protocol. So 0 is a topology change. That's already I have mentioned that over there. If you see, 0 is a topology change, right? And T7 is a topology change acknowledgement, right? And then after that, we have a agreement, proposal, forwarding, and learning. Again, no need to remember that this thing. And this type of BPD is called as a BPD version 2. In the PVST, that BPD we have seen that that's called as a BPD version 0. If you see, let me show you that. And this one is 2, right? So he mentioned that in the 80 in the BPD of the 801D, 1D means what? It's talking about the PVST is a version 0. So if you see the proposal and agreement handshake, so when the switch A is sending the proposal flag to the switch B, what switch B is do that? Switch B feels that, okay, mine is a lower bridge ID. Sorry, mine is a higher bridge ID than the switch A. It will send the agreement. So once he will send the agreement, the election of the port will be defined DP and RP. Now, what happened? And that time, what happened? This one behind the switch 3, if you see that, behind the switch 2, there is a switch 3 was there. So they was in the blocking state, or we can call it the discarding state. So once the election has done, DP and RP has selected. Now we are sending the proposal to the switch C, and he will give the agreement. So if you read this line, right? Switch A send a proposal flag. Yes, I'm sorry. Switch A send a proposal message, right? Switch A send the proposal message to the switch B, right? With the configuration review. This is just a flag set to the switch B, proposing that it's a designated switch. After receiving the proposal message, once the switch B receive the proposal message, right? It's saying that, hey, let me elect the port new road port with the proposal message, and all the non-edge port will go in the blocking state. All the non-edge port will go in the blocking state. And then what happened after that? I'm going to send the agreement message to the root. After receiving the agreement message, what happened? The new root port, from the new root port, after receiving the agreement message from the switch B, switch A also immediately transition its designated port into the forwarding state. To just prevent the loop, we are putting this port into the blocking state. All the non-edge port, no loops in the network can form because switch B blocked all the non-edge port, right? So if there is no any port, and I'm gonna make an election on this particular port, then what happened? There will be no loop. Take example, if they will not block the port. Take example, if they will not block this port. So let's take example, what I can do that in this scenario. So we have a switch 1, we have a switch 2, we have a switch 3. And take example, if I'm gonna do the election on every segment simultaneously, try to understand this concept. If I'm not gonna block this port, then what happened? Maybe what happened? He will become the DP, he will become the RP, and he will also become the RP, and he will also become a DP. Anything could be happen, right? So assume that, is it possible that one non-root bridge can have a 2 RP? No. On a one non-root bridge, you will only have a 1 RP. You will not have a multiple RP. So that's why, to avoid this problem, what they are doing that. So once the election is going on this particular segment, they will block this particular port. Once the election will be done on this Y, then the proposal and agreement will be happening over there. Now, this is according to the Cisco documents that we have. How actually works, let me show you that. So I have a switch 1. I have a switch 2 as well. So I'm going to enable some debug, right? So yes, yes. See, RPVST is a single command. You just need to go on the switches and just say that, okay, spanning tree mode RPVST, that's done. That's how you can enable the RPVST. That's not a big deal. You need to understand the concept, right? How these are the different from the PVST protocol, whatever the changes they made it, right? So spanning tree sound, if you see which protocol is enabled right now, okay, that's fine. This is running the RPVST mode. So what I can do that, first of all, is the switch 1, and same thing on the switch 2. Let me check which protocol is enabled. So spanning tree mode. So spanning tree summary, and it's there with the RPVST mode. So if you want to enable it, how you can enable it? You just need to put the command spanning tree mode rapid VST. This is how you can change the mode, right? Host name will be switch to. Now what I can do that, I'm just gonna shut down all the interface which I don't need, right? So I just have a 0/0, so I'm gonna shut down all the port right now. From E0/0 to 3, interface range E0/0 to 3, then E1/0 to 3, shut down. Same thing. On this guy, shut down. Now I'm going to enable some debug. Debug spanning tree, events, debug spanning tree, switch state. Hold on, I think so. Debug spanning tree. EST not. I think the event will show that all message. Let me check. I think the event will show that all message. Same thing on the switch 2, switch 1 now. Debug spanning tree events. Right. And now, so both the interfaces down right now. Understand this concept. So ETH0/0. I'm not going to put the enter right now. Same thing on the ETH0/0. I'm not going to put the enter right now. So this interface is down. Okay. Of course, you know that, right? This guy is a 0/100 as a MAC address. This guy is a 0/200 as a MAC address. Priority again 32768 plus VLAN number 1. 32768 plus VLAN number 1, right? What happened if I'm on this port now? Have a look. Come on. Come on. Sorry, I need to put the no shutdown. No shutdown and no shutdown. Hit enter, hit enter. Done. You all and you all. So if you see that, what happened? Once I put the no shutdown command, right? If you see, this port has initialized into the RSTP protocol at this point, right? 14 seconds. This is again, let me remind this you. This is hour, this is second, sorry, this is minute, and this is second, and this is the millisecond, right? Can you see that? Once I put this port, initializing this port into the 0/0, right? What happened in the RST flow? I just put the no shutdown command over there. I send the proposal, and what I'm saying that, hey, this is my designated port. This guy send the proposal and say that this is the DP port. What happened? Understand the theory part. Theory, we have seen that what? Once he will send the switch 1 as a proposal, switch 2 will receive it, and he will send the agreement. But in practically, it's little different. In practically, what happened when the switch 2 will on this port, what happened? This will also go in the designated, and he's sending the proposal from this one. So initially, both will be a DP and DP. Once the switch 2 will receive this BPDU, right? Then switch 2 will, okay, I didn't, okay, the switch 1 has a lower MAC address, so they will change this port into the RP. And then they will send the agreement flag. Can you see that? I'm updating my role because of the superior BPDU I have received, best BPDU I have received on the switch 2. Right? Best BPDU I have received on the switch 2. That's why I'm sending the agreement flag to the switch 1. So initially what happened? It is something like that. Switch 1, we have a switch 2. Both the switches is treated like a DP and DP. It means that both the switches behave like a root bridge and root bridge. They will send the proposal and they will send the proposal, right? Once the switch 2 will get to know that, okay, switch 1 has a lower bridge ID, they will send the agreement flag. And they will then check the port roles as a DP and RP, and this guy will become the root bridge, this guy will become the non-root bridge. This is called a three-way handshake process. Practically is happening like this way. So in some books, they just written like the proposal and agreement, but in a practically, they are doing the three-way handshake process. That's how your RSTP works, guys. Questions?
If 6-3 also there, that time also same three-way handshake, right?
Yeah, same. Sorry, what do you repeat? Can you repeat the last?
If after switch 1, switch 2 is finished, the
Yeah, same
handshaking.
three-way handshake process will happen over there. Yeah, same. In the entire network, and later the three-way handshake process will be done.
Oh,
So all this process, right, has done in just a 1 second. Can you see that? They started the process. If you see the timer right now, which is not possible in the PBST protocol. See, the timer is over 11 seconds, right? I initializing this port in the 11 second, and at the 110 millisecond, right? In the 480 millisecond, what happened? I'm updating my roles, and I'm saying that my port is a root port. So in just a 300 millisecond, right? I'm not even saying the second, right? I'm not saying the second. In just a 300 millisecond, my network will get converged. So up to 1 second, it's saying that in a up to 1 second, it required the RST protocol to bring the interface up. So now your PC is not gonna wait for the so longer. Now the PC is not gonna wait for the longer. Your network will converge in the 1 second. So that's why now it is layer 2, that because of the RPVST protocol, layer 2 is much faster. Layer 2 is much faster than the layer 3 protocol. So now assume that, like, what RPVST allow you? RPVST say, hey, I will converge my network in the 1 second, right? That's how the things are working. How about the layer 3 protocols? If you guys remember that, like, you have a OSPF, we have a EAGRP protocol, we have a RIP protocol, we have a BGP protocol. All these 3 protocols, if you see that, they are dealing in the second. OSPF deal with the 10 to 40 second, that's a hello and hold on time. EAGRP 5 to 50, RIP is just 60 to 30 to 32 to 40, right? And BGP has a 60 to 180. They are dealing in the second, man, right? But RPV is still in the 1 second, up to 1 second, or we can say the millisecond. So RPVST is much faster than now the layer 3 when we do the debug event. when you shut down the interface, right? Just shut down the interface and do the debug and then do the no shutdown. What does it exactly do? You mind to explain again? Nasi, the debug command is just gonna give you the output, right? It will give you this flag message. Don't ever do in the production network. Never ever do in the production network. Just for the learning perspective, you can do this debug. Okay, if you wanna learn the things in a proper way, right? If you wanna see the behavior, then you can do that. Otherwise, what happened? Let me tell you. If I'm not gonna do the debug, let's take example. I'm gonna shut down this interface. I'm gonna shut down this interface. Both the interfaces down right now. Okay, this both the interfaces down. So there's no any spanning tree is going on. So if you put the command also spanning tree is not exist right now because the link is down. So if I'm gonna shut down this link, you will not see this messages, right? So you will not see how does the RSTP works in the background. So if I'm gonna say the no shutdown, have a look. Can you see any debugs over there? Can you see that how the proposal and agreement is going on? No, you cannot see that. But if you see my convergence has done, man, there is no listening and learning. Do so spanning tree, my convergence has done. So you will not see the listening those things, proposal and agreement. But if you not see that how the things are working in the background, then you can use the debug command. Like you want to see the packet structure, then you can see the debug command. But debug command you can do in the practice purpose, but never ever do in the production network, because if you enable the debug, right, it's utilizing the lots of resources of your data, because he's keeps sending the syslog messages on your screen, right? He keeps sending the syslog message on your screen. So if he will keep sending the syslog message on your screen, then what happened? Your CPU will be high, your buffer will be, memory consumption will be high over there, right? So there will be a chance of your router will get down.
So what is the syslog messages? What is that?
This is the proposal bits we have. You were not there over here, then what I explained over there, this part?
I think I missed a little bit.
Did you miss this part?
Yeah, I missed it. Yeah, that's
Then,
right. Yeah.
then you have to watch the video. So basically, this proposal things, I have shown you this over here right now.
Okay.
Okay, not a big one.
I will check the
Normally
recording
what happens,
again.
let me explain you again. So
Hmm?
hold on. I'm explaining you. So normally what happened, these are the switches we have, right? So these switches are the root bridge. So initially what happened, the switch one will have a lower MAC address A, right? B, C, these are the MAC address. I haven't put the priority over there. So there is no port election. So he will send the BPD with the proposal flag on, right? When the switch will receive, switch two will receive it, they will see that, okay, switch A has a lower MAC address. They will change the port with the RP, and they will put this port in the blocking state, and they will send the agreement flag from this one. Once the switch one will receive the agreement, they will change this port into the DP. This is how the election is working in the RSTP protocol. Same thing, once the election will be done on this particular segment, now this port will be on. And now again, he will send the proposal. Switch 3 will receive the proposal. They will send the agreement to the switch 2. And they will change the port to the RP, and they will change the port to the DP. So same thing, I have shown you that over here in the debug.
It's just a matter of transmitting the messages, right?
Right. This
That's
is
it.
just a message. These are the just same message I have shown you in the debug command, so that you can understand it properly.
Okay, so there is no other function of that, just
No,
transmitting the
that's
message.
that's a just message only. So this is called the three-way handshake process.
Okay.
If somebody will ask you the three-way handshake process in the RSTP protocol, then you need to explain this thing, right? Proposal, agreement, and proposal, and agreement.
Okay, no problem. That's fine. Thank you so much.
Okay, so that's a difference. So again, one more thing, RSTP is only gonna make a action on the non-edge port, right? Non-edge port, and at the same time, on the point-to-point link.
That's what I know that. Yeah.
Point-to-point link is what? It should be the full duplex.
Full duplex. Full duplex means sending acknowledgement.
Sending it is
basically.
right. So RSTP is not gonna work on the half duplex. On a half duplex, it's not gonna work it.
So half duplex is kind of a one-way traffic.
Yeah,
just
one way time.
Oh, okay. No.
Now, one more thing in the RSTP we have, right? What? See, there's a lots of things according to the CCMP level. We have those things only. So one more thing that I want to discuss about the RSTP, that's called as the port roles. So if I talk about the port role, so we have one extra port over here. So normally you already have a root port, right? You already have a DP port. You already have an alternate port that you have seen in the previously. Another port we have introduced as a backup port. So backup port, this port only comes in the picture when you have a half duplex. It means that link type will be what? So either the link type will be what? It's a point to point. The point to point means what? It's a full duplex, right? Or you have a shared. Shared means what? You have a half duplex. So when you have a hub in the picture, right? Or we can say the half duplex in the picture, then you have a backup port comes in the picture. For example, you have a switch one, right? And this is we have a block hub over there. So in this case, what happened? One port will be DP and another port will be the backup. So backup port only comes in the picture when you have when switch has a connectivity with the hub. Right? Let me show you this thing. I can show you in the practical way because I have a hub in the Cisco packet tracer. So one more thing, the good thing about the RPSD, you don't need to enable the backmode pass, uplink pass feature, those things. We don't have a requirement of these things now because it's already a faster protocol. So let's have a look. So I'll connect this. I have a hub. So I'll take a generic one and I'll take a one switch. And I'll connect this guy, 2 ports. Right? And I'll change this mode of this guys. Is what? Spanning tree PVST. Sorry, spanning tree mode RPVST. Right? Now if the source spanning tree, what happened? You have backup. You will never see the discarding state. Let me tell you, you will always see the blocking. Discarding, you will not see. In the theory, it's a discarding, but in a practical, you will see the blocking. So here is the backup ports we have. So backup only comes in the picture when you have a half duplex shared medium. So maybe you have a question, hey, law, I can see the shade over here as well. So if you see, you can also see the shade over there, right? So that's a bug, but still, this is the full duplex, right? This is the full duplex. But this is the problem with the, web IOU. What you can do that simply interface 0/0 spanning tree link type will be what? I can see the point to point. So you have a link type shade of point to point. I'll make this guy the point to point. Same thing on the switch 2 right now. Interface. That's a issue with the web IO, not the spanning tree link type will be point to point. So now the do spanning tree now. Let's change the point. All got it? Anyone has any questions?
No.
Great. Now, the next protocol that I have is called as a MST protocol. Okay, I'll show you some theory part from the book, right? Now there. So there is no difference in the BPDU perspective. A slighter difference is there, right? If I talk about the MST protocol, there's a slighter difference in the MSTP BPDU, right, compared to the RSTP, but they are using the same mechanism like a flag the same flag, proposal and agreement. So we have done with this part, BPD filtering and BPD guard, root guard, these are the same things they have discussed, right? Rapid PST and MSTP protocol. I will give you this link. So if you want to read the RSTP, you can read from here. I'll put the message in the chat. This link is good. Because if you're going to learn the RSTP from this book, right, you will get confused. So if you see that, this is saying that a point-to-point ports are automatically determined by the duplex mode. Full duplex are considered as a point-to-point because only the two switches can be present on the link. And STP conversions can occur quickly over the point-to-point link through the RSTP handshake process. Handshake means what? You have a proposal agreement, right? Half duplex ports, on the other hand, are considered to be a shared media, right? That's I have just shown you in the Cisco packet tracer. The shared media, that's how comes in the picture, right? They are not a point-to-point ports. STP convergence on a half duplex port must occur between several directly connected switches. Therefore, the traditional 80.1D style convergence must be used. What is saying that if you have a half duplex, RSTP is still gonna work, but they will use the 80.1D matlab, it's gonna use the PBST protocol. The convergence like a PBST one, not the PBST protocol, the convergence is like a PBST one. But normally we don't see the hub nowadays in the picture, right? So no need to worry about that. But yeah, this kind of scenario they will ask you in the, what we call, in the interview. They're asking this kind of scenario. So if you see that they send the proposal, they send the agreement, right? So remaining the point-to-point link will go in the blocking, right? But this is the edge port. Edge port will never go in the blocking because edge port is like what? We are not going to do the RSTP over there. We are going to do the RSTP on this particular, because election is going to happen on this particular port, not this port. So this port will still on, this port will go in the blocking. Very simple command. You just need to go change the type, link type. We have already seen that. If you want to enable the port first, you can enable the port first. We did this part. Change the mode is like a spine key mode, rapid PST. Okay, so here is a very good output that I have. So if you see this output is saying that PRSTP, right? PRSTP means what? If you have a topology like this way, take example. Let me show you this practically. I'll change this as a spine key mode PST. Come on. So one side is running with the RST protocol, another side is running with the PBST protocol, right? So they are compatible. There is no issue with the communication. So span if you see, it's saying that we are with the STP. STP means what? PBST. So switch one is running with the. So these are the scenario based question they will ask you, right? Switch one is running with the RPBST protocol, and switch two is running with the PBST protocol, right? So in this case, what happened? If you just check the database table of the switch one, it will show you the point to point, but it will mention over there, it's a peer is a, my neighbor. Peer means what? Switch one is saying that I'm present on the switch one. Switch one is saying that my peer is a STP running. STP means what? They are running with the PBST protocol. But if you see on this guy, do so spine tree, they are just showing the normal PT. Because switch two right? He will send the, first he will send the proposal, right? He will not respond it because PBST doesn't understand the proposal, right? PBST, how many bits we have a PBST? TC or TC acknowledgement, that's all, right? 0 and 7. Remaining all the bits are reserved. But this guy is going to use the all bits, TC, TC acknowledgement, proposal, agreement, learning, forwarding, port rules, everything. So he will send the proposal. He will say that, okay, nothing. I'm not going to consider the proposal because I don't know the proposal. So he will wait for the 30 seconds. After that, what happened? He will say, okay, let me convert this port as a traditional. He will assume that if the switch 1 is not getting the response from the switch 2, if the switch 1 is not getting the agreement flag from the switch 2, slowly what happened? Slowly the PBST will jump to the, slowly RPBST will jump to the PBST. Slowly they will jump to the PBST convergence if they are not getting the agreement flag from the neighboring switches. But they are actually of RPBST protocol. Just for the convergence, what happened? They will jump to the PBST. Okay, so we have a RSTP on the switch 1 side, and the switch 2 side is the PBST protocol. So how you can identify based on the PRSTP? If the PRSTP output is saying that, it means that you're running with the, your neighbor is running with the PBST protocol or older protocol. Now what? So now we have a MST1, multiple spanning tree protocol. See, now let's understand the concept of the MSTP now. So basically, if you think about the, again, let me recap this thing. CST was a common and it was a great protocol according to the CPU perspective. According to the CPU, it is amazing one. Understand the guys concept because MSTP is a combination of all this protocol. CST is amazing with the CPU. But CST is a bad for the what? Layer 2 load balancing, right? And we are not going to utilize the complete path, not utilize all the resources. If you're going to implement the CST, because for all the VLAN, we have a single load bridge. Then we came with the concept is called the PVST. PVST was amazing with this thing, right? We have a layer 2 load balancing. We can achieve, these are not possible. So I'll just put the cross mark. Layer 2 load balancing, we can achieve it. And we have a utilize all the resources. Now, how about the CPU perspective? It's a per VLAN. For the CPU perspective, right, this protocol is a very bad because for each VLAN, you have a separate root bridge. So if you have a separate root bridge for each VLAN, you have a separate spanning tree algorithm. So for the VLAN number 10, we have algorithm, VLAN number 20, we have algorithm, VLAN number 30, we have algorithm, VLAN number 40, we have algorithm. So can you imagine that in PBST, what happened for the VLAN number 10, we have a one root bridge. For the VLAN number 20, we have a root bridge. For the VLAN number 30, we have a root bridge. And for the VLAN number 40, we have a root bridge. Can you see that? But in the CST, what happened? For the VLAN number 10, 20, 30, 40, whatever the VLANs we have a single root bridge. I have a 4 root bridge, if you see. I have a single root bridge. So of course, the CPU will be less over there. CPU will be high over there. So PBST CPU perspective is very bad, right? But again, what happened? Layer 2 load balancing, we can achieve, you can utilize all the resources. One more good thing about the per PBST is what? Sorry, one more bad thing about the PBST is what? It's a slow. Again, it's a bad thing. Then we have a concept. Yeah, questions? So again, we have come with the concept is what? We came with the concept is called the RPBST protocol. RPBST said that, okay, it seemed like a rapid per VLAN, rapid per VLAN spanning tree protocol. Good thing, understand, we have a layer 2 load balancing, right? Utilize all the resources and fast. Only again, bad part is what? CPU. Because for each VLAN, again, I have a separate root bridge. VLAN 10, 20, 30, 40, even if I'm going to see example. So even if I'm going to run the RPBST protocol in this case, for the VLAN number 10, 20, 30, 40, I have a separate root bridge. CPU perspective, it's very bad. So what we have introduced? So we have seen these are the problems, right? We have seen these are the problems we have. One more thing before I'm going to start the MSTP, I just want to show you one more part. So if you see the RPVST Wikipedia, is it? No. Just want to show you the timing, right? Nothing else. So you see that in RSTP has came in the market in 2001. 90s, almost 10 years, right? 10 to 15 years they took to make a faster. And they given the MSTP over there? I think so not. So in 2002 to 2005, they have in between that they have came with the MSTP protocol. So yeah, timers like they took the many years, right, to realize that PBST is a very slow protocol. So it came in the 2001. It was in the 90s time, it was in the 80s time, 1980s time, and it was in the 90s time. Each is it a each different scenario has a different protocol? Yes, man. Different scenario for the different protocol. So if you have a low CPU, right, higher CPU, you need to stick with the scenario. But nowadays, it is a recommendation to do that the RPBST protocol on the Cisco switches, or if you have a different vendor, you can go with the RSTP protocol. But again, now I'll give you the another good thing about the MSTP is what? MST is a combination of each one. What I told you that if I have a low CPU, I have to go with the CST. But do I have a CST? No, I don't have a CST. I cannot enable the CST. But MSTP saying that, hey, don't worry about that. Don't worry about that. MSTP by default, if you don't do any kind of manipulation, MSTP is a combination of, it's a combination of CST and RPBST. Why I'm not saying the PBST protocol? Because PBST and RPBST both are same, right? Only the difference is what? If you see, slow and fast. That's a major difference. So MST is a combination of what? CST and RPBST. It means that by default, right? MST is behave like a, by default, multiple span tree protocol is behave like a CST. It means that for all the VLAN, right? For all the VLAN, you have a one root bridge. After that, if you want to do that manipulation, you can do that. So let me show you this thing. So what I can do that, I'll just go to the device, stop this box, and go to the manage liberties. And then STP we have, not this one, this for the CC. Okay, I'll change over here the protocol mode. Switch 1, switch 2, switch 3, right? What I can do that, I'm simply gonna run the MSTP. Before I'm gonna do the MSTP, I'm just gonna configure the VLAN. So what I can do that, I'm just gonna configure the 9 VLANs right now. VLAN 10 to 20, 30, 40, 50, 60, 70, 80, 90, right? 9 VLANs I'm gonna configure. I'll explain you why I'm gonna configure the 9 VLANs. Don't worry about that. So before I'm gonna do that, I'll make sure that the interface should be the trunk. so that the VLAN will be a part of the interface, right? So eventually it will make a request to the SysO, it will make a request to the Sys3, they will make a trunk on this particular segment. They will make a trunk on this particular segment. We need to do the on this particular one, Sys2. Switch port trunk encapsulation dot 1Q, switch port mode trunk, right? That's all. And here we go. That's all. Done. Now what? Very simple command. I just gonna enable the VLANs as the VLAN number 10, 20, 30, 40, 50, 60, 70, 80, 90. Same VLAN I'm going to configure on all the switches right now. Switch 2. I'm just going to show you that the behavior of the MSTP. And all done. Now have a look on the switch one. What I can do that I say the spanning tree mode what MST multiple spanning tree mode. The meaning of multiple means what? The meaning of multiple means it doesn't mean that it's a combination of the CST and RPBST. Right? The meaning of multiple means you will see that. Hold on. I'll explain you the meaning of multiple. There's a word of multiple. It has some meaning. It doesn't meaning that there's a combination of CST and RPBST. It has some meaning. I'll explain you that. Mode change to this guy. Same thing on the switch 2 and same thing on the switch 3. Sorry, spanning tree mode MST. Now what I can do that? Have a look. So spanning tree, right? Of course, this guy has a lower MAC address, right? So this guy will be the root bridge, of course. That's not a big deal, but that's I don't want to look up right now. The most important part that I want to show you that. So spanning tree MST, right? Configuration. What you can see that. Instance means what? Algorithm. One algorithm. It's now behave like a what? CST protocol. All VLANs, right? Whatever the VLANs you have, right, is gonna map with us. So does it, I just create the nine VLANs, right? 10, 20. I just create this VLANs 10, 20, 30, 40, 50, 60, 70, 80, 90. Right? You can see that I'm coming to this picture right now, but if you see that right now, all the VLANs, right? All VLANs, whatever the VLANs you have range, they are converted into the single instance. And that's how CSTs work. CST is a common spanning tree protocol. Common is what? For all the VLAN, you have a single algorithm. You have a single algorithm. So default behavior is what? CST. I'm running with a single algorithm, man. So I have a one root bridge right now. You can see that by default instance 0 is created. It's like a VLAN number 1. Understand this concept. By default on the switch side, what happened? You have a VLAN number 1. And all the ports are the part of the VLAN number 1. If you see the Cisco packet, so let me show you this thing. If you go to the switch and say that so is spanning, so VLAN brief, what you can find that. So by default, you have VLAN number 1 and all the ports are the part of the VLAN number 1. Same thing in an MST protocol. What happened? Once you configure the MST protocol, once you define the spanning tree mode MST, what happened? By default, the switches will create the MST will create the one instance. That instance is the 0 instance. And by default, all the ports, not all the ports, sorry, all the VLANs are mapped to this particular instance. It means that CST protocol. I can save the huge number of resources now. Huge number of CPU, I can save it. I'm also, which one is the root bridge? If you see that, spanning tree, so spanning tree, Switch 1 is a root bridge, not a big deal. Switch 1 is a root bridge, not a big deal. All the ports are the designated forwarding, right? The switch 1. This should be the RP port. If you go to the switch 2 right now, so span 3, this is the E0/0 is the RP, and E0/1 is a DP. That's this guy. Same election, right? No issue, right? DP and DP. We have a root bridge. We have non-root bridge. We have a non-root bridge. We have again RP and RP. And again, we have a DP, and this guy's go in the blocking. See? So it's 3 right now. So it's span 3. Only the thing is what right now, the most important concept, by default, if you don't do any configuration, all things are mapped with the VLAN instance number 0. So if you want to see the behavior of the CST, you can see that over here, right? But in this behavior, in the CST, in the default behavior, what happened? Can I utilize this particular link over there? No. This is my what link? This is my 100 meg link. Take example. This is my 100 meg link, and this is my 100 meg link. So can I send my traffic from this particular link? No, I cannot send the traffic from this particular link because these ports are the blocking port. Blocking port cannot accept the data traffic. They can only accept the BPD traffic. If you guys remember that we have seen this practical, right? The BPD, a blocking port can receive the BPD packet, but cannot transmit it. So I cannot send my data traffic. So if I'm not going to send the data traffic, this link will be totally wastage. Check my layer 2 load balancing video, previously. I have explained this concept. The complete path, the switches is wastage, right? If you have a single root bridge. So what I can do now, see, it is awesome. If you have a less number of what we call, if you have a less number of CPU on the device side, you can go with the like a behavior, default behavior like a CST way. But right now, what happened? I have these range of VLANs. Can you see that? So VLAN brief right now. I have a 10 to 19. Same thing if you see that. So VLAN brief. On a switch 3 as well. Switch 2, sorry. Now switch 3. What I can do that? I do have ability because it's now mapped. It's a mapping, right? So MST allow you the mapping concept. Mapping means what? I can see that 10. In the PVST protocol, what happened? One switch, one VLAN. You can make the one switch as a 2 VLAN root bridge. But here I can do the mapping of that when I can say the 10, 20, and 30. For this particular VLAN, switch 1 will become the root bridge. I can do that. For the 40, 50, and so that's why I keep the 9 VLANs over there. You can take any range. I just took the 9 VLANs. Switch 2 will be the root bridge. And 70, 80, 90, the switch 3 will be the root. This mapping, these are the what? Mapping we need to create. So I can call this would be the instance number 1. By default, the instance 0 is present, right? I can get the multiple instance number 2, and instance number 3. These instance, that user defined instance, that's I'm going to create this instance, and I'm going to map this instance, right, to the VLAN. So instance 1 is going to map with the 10, 20, 30. Instance 2 is going to map with the VLAN number 40, 50, 60. Instance 3 is being mapped with the 70, 80, 90. For the instance number 1, switch 1 will become the root bridge. For the instance number 2, switch 2 will become the root bridge. For the instance number 3, switch 3 will become the root bridge. So in future, if I'm going to add another VLAN, for example, I have a VLAN number 100, that's I'm going to add. I can add it. So I just need to create the VLAN number 100, or I'll just going to map this 100 VLAN into the instance number 3. That's all. I'm just going to create the VLAN 100. I'm just going to map the 100 to the instance 3. So automatically what happened? For the VLAN number 100 as well, the switch 3 will become the root bridge. remaining now what? Apart from these VLANs, take example, I have a 10, 20, 30, 40, 50, 60, 70, 80, 90. So total, how many instances we have? Instance 0 was already there. 1, 2, 3, 4. Total, we have 4 instances. 1, 2, 3, and 0. So whatever the VLANs that is not mapped, whatever the VLANs that is not mapped with the user-defined instance will be automatically go to the instance 0. So take example, 1 to 9, 11 to 90, 21 to 29, 31 to 39, 41 to 50, 49, 51 to 51 to 59, 61 to 69, 71 to 79, 81 to 90, 89, and from 91 to till 4094, all they are mapped with the instance number 0. Have a look. Let me create this instance now. So for this instance, what happened? You have a few extra configuration. You need to first go spanning tree, MST mode configuration. You need to jump in this box, the configuration box, and here you can define the name. So I can define the name will be CCI. You can, it's not a mandatory, but it's a best practice to define the name so that you can remember the things easily. But the default name is what? The default name is a null. Default revision is what? It's 0. Right? Instance configured means what? 1, which is the 0 instance. This revision number, don't confuse with the configuration revision number that you have seen in the BTP protocol. In a configuration revision number, CR number in the BTP, that was a dynamically created. So if I'm going to create the VLAN number 10, automatically what happened? The CR will be added by 1. If I create the VLAN number 20, CR will be added by 1. If I create the VLAN number 30, CR will be added by 1. If I delete the VLAN, CR will be added by 1. But this revision number is a static way, right? You need to manually define it, this revision number. So there is no concept of those things dynamically over here. The use case of this revision number is what? So whenever the network engineers will modify the database, the MST database, whenever they change in the MST configuration, what they will do that they will manually change the revision number 1. So for example, right now it's 0. So it means that there is no change, it's a default 1. So now if I'm going to configure it, take example, I say the name will be CCI, revision number will be 1. So I'm saying now 1. It means that I made some changes. So some other engineer will, they perform the lookup, right? They can say that, okay, now the revision number 1, previously it was 0, now it's 1. So based on that one, they can identify, okay, someone has made the modification in my database table. Now I can say the instance number what? Instance number 1, I say the VLAN number 10, 28, 30. Instance number 2, can you see the same mapping I'm doing again? VLAN number 40, 50, and 60. Instance number 3, VLAN number 70, 80, 90. That's all. Same configuration, I'm going to do that on the switch through now. Spanning tree mode. You need to, sorry, MST configuration. You need to first go in the configuration mode. I said the name will be CCI. Make sure that these all are the same name. Revision will be 1. Instance will be 1. VLAN number 10, 20, 30. Instance number 2, VLAN number 40, 50, 60. Instance number 3, 70, 80, 90. That's done. Same configuration I'm going to do on our switch 3 as well. The spanning tree MST configuration, you need to go in the configuration mode. Then what? Name will be CCI. The default name is null. Default revision is 0. I'm just going to add the 1. It means that someone has changed the database. Which database? MST database, MST configuration. So the instance 1, VLAN number 10, 20, 30. Instance number 2, right? You have this instance range, VLAN number 40, 50, 60. And instance 3, we have so the VLAN number 70, 80, and 90. Now we are done. So now if you see the source spanning tree MST configuration, how many instances you have? 4 now. 1 is 0. You see that 1 to 9, 11 to 90, 21 to 29, all this VLAN which are not mapped with the user-defined instance, will move to the instance 0. Instance 1, 10, 20, 30, instance 2, 30, 40, 50, 60, 3 is a 70, 80, 90. The name is a CCI now, revision is 1. I'm done, still not. The reason is still the switch 1 is the root bridge for the all the VLANs or for the all the instances. So if you see the source spanning tree, right? Can you see that? For the instance 0, I'm the root bridge. Switch 1 is saying that I'm the root bridge. For the instance number 1, I'm still a root bridge, dude. For the instance number 2, I'm still the root bridge. For the instance number 3, I'm still the root bridge. So you need to change this behavior. What you can do that? I can say that spanning tree MST1, you will be the priority. I'm gonna make, so you can do this way as well. Root priority, you can call it, right? Or the best practice is what? You can define the priority. I can say the priority will be 0. So automatically you will become the root bridge for the MST1. Same thing on the switch 3. What I can tell this guy, spanning tree MST3, priority will be what? 0. What I can tell this guy switch 2 now, spanning tree MST will be what? Priority will be 0. So now understand the concept. Same behavior I have just achieved now. So now he will be the root bridge also. He will be also root bridge. So he is the root bridge for what? He is the root bridge for the instance number 0, which is by default, right? And instance number 1. So in the instance number 1, what are the VLANs we have? 10, 20, and 30. Apart from the instance 0, you have this range of the VLAN. For all this VLAN, also the switch 1 is the root bridge. For the instance number 2, what I did, man, I just said the VLAN number 30, 40, 50, and 60. For these guys, switch 2 is a root bridge. For the instance number 3, right, that's for the VLAN number 70, 80, and 90. This is the root bridge. So eventually you can see that I have a multiple root bridge in my network. I have a multiple root bridge in my network. So I'm now utilizing, so according to the switch 3, I'm the root bridge. According to the instance number 3, this port should not go in the blocking. So it means that for the instance number 3, I can receive the data traffic on this particular port, but I cannot, send and receive the data traffic according to the instance 1 and instance 0. Because according to the instance 1 and instance 0, he will be the blocking port. So now you can see that on a switch 2, do switch spanning tree, what you will find that switch 2 is a MST0. This is the root bridge according to the switch 2 perspective, right? If you go down for the MST1 as well, switch 1 is the root bridge, but for the MST2, I'm the root bridge. But for the MST3, switch 3 is the root bridge. If you see the same thing on the switch 3 now, do switch spanning tree, what you can find that for the MST0, I'm on the switch 3 right now, right? Switch 1 is the root bridge, and according to this one, these ports are blocking, right? But if you go down for the MST1 again, what happened? I have a blocking port because he is the root bridge. MST2, these port is the blocking. Can you see that? Now the amazing thing is happening, right? So let me cover this part. I'll explain you over here. So for the MST number 1 and 0, this is the blocking port. For MST number 2, this is the blocking port. But for the MST number 3, right, 0/0 and 0/1, both are the DP and DP port. See? For the MST3, I'm the root bridge, and my both ports are the DP and DP. Simple configuration, guys. Let me write on this thing. So RPVST right? MSTP, or it's the MST as well. Spanning tree mode, MST. What you can the 10, 20 VLAN number, switch 1, switch 2, and switch 3. VLAN number 10, 20, 60, 70, 80, 90. And then what you can do that? Switch 1, you need to go under the interface range E0/0 to 1, switch port from encapsulation .1 to switch port mode from, and on the switch 2 as well, same configuration just applied, that's fine. Even if you're not gonna do on the switch 2, then what happened, this port will become a trunk, right? Because they will negotiate it, right? Just for the easy way, let's make it easy peasy. And now we have a MST configuration. So what I can do that, spanning tree mode, not spanning tree MST configuration. First you need to go in the spanning MST, then you can define the name as a CCI, revision number is the one. This revision number is not automatically added. You need to manually add the revision number whenever something had changed in my database table, right? Then you have a instance, one VLAN number 10, 20, 30. Instance number 2, VLAN number 40, 50, 60. And instance number 3, that's VLAN number 70, 80, 90. And here we go. So this configuration you need to do on the switch 1, switch 2, and switch 3. Then after that, what you have to do that? On the switch 1, I can say that spanning tree MST number 1 priority will be 0. Switch 2, you can say that same thing. Go to MST number 2. On a switch 3, right? Same thing, you can do that. MST number 3. You can also use this command instead of the priority. You can also use the right root primary. But again, this is not useful, right? People are not using this thing in the production, right? Because the primary keyword is not reducing the priority 0. So priority is a 0 is the lower priority, best priority, right? So no one can, like, target your switches, right? I like to become the, like, no one can claim it with any other priority, because 0 is the last one, right? So that's my best way to give the command priority. This is the way that you can implement the spanning tree, guys. I know the configuration is longer in the MST protocol. That's the one bad part, right? If I talk about the bad perspective of the spanning tree, MST spanning tree, they only have a long configuration. Apart from this thing, MST is amazing because MST offers you, right? MST offers you what? They offer you the CST behavior at the same time as a rapid PST behavior. Now, if I talk about the, about the BPDU perspective, right? If you talk about the Wireshark perspective, the only thing is what? So these information, right? If you see that these information, I'm so sorry. Let me remove this guy. Okay. So basically what happened, let me explain over here. So the BPDU still will be same, right? Only the thing is what? These MST, right? Configuration, instance configuration, right? What the switches is, what the MST is going to do that, they will generate the hash value for this guy. And this hash value will be present in your BPDU. So in your BPDU, you will not see like an instance one that has a VLAN 10, 20, 30, instance two that has a 50, 40, 60, instance 3, we have a 70, 80, 90. You will not have a like this way. You will have a hash value. So they will convert this data into some hash value, right? Like this way. So you will have a hash value, and that hash value will be shared in the MST, sorry, in the BPDU. So in a normal BPDU, what happened? They will added the extra field over there, right? This extra field is known as a, what we call, something is known as extension name. Forget the name. MST extents. So normal BPD, what did they do that? They added the MST extension. MST extension means what? Now we have this field is gonna store the MST information, and this guy has a hash information of that one. So if you see that, let me show you. I can have a look for this guy as well. So if you see this is normal BPU, let me take a sneak of this guy, and then I'll compare with this person. And MST protocol. What cloud SAP. Again, at the NP label, these things are not so important, right? The Wireshark capture, those things, because people get confused. The fresher people who has the fresher in the networking, right? So get confused. But yeah, these things are important when you have a experience of the 5 years and 10 years of experience, and when you planning for the CCI lab exam and those things, right? These things are very important. But at the CCN and CCNP level, these things are, will confuse you. So I'm not going to show you the invest your time. Yeah, once you are ready for the protocol, right? Once you become the expert, right? Once you have done the reading the books, once you have done with the watching the video, once you have done with the practical, now you have a good exposure in the MST and PVST protocol, in the RST protocol. Then after that, apply the logics in the debug. And then after that, you can check the Wireshark capture. Once you become the familiar with the protocol, then you can do the more digging in the debug and the Wireshark. Then you can come, okay, log, can you help me with this Wireshark? And then log, can you help me with the this debug? Definitely, I'll help you with the each and every flags over there. But right now, I'm not explaining all these flags because these things are not important for you, even, right? So if you see the spanning tree protocol we have, that's a MSTP1, multiple spanning tree protocol. Here's the MST extension. So same things we have BPD flag, the proposal agreement, same things is there, right? To position agreement, forwarding, learning, report proposal to position change. Apart from this thing, right? What we have over there, I have a MST extension. In this MST extension, I have all the things over there, like names, revision number, and now we have these are my digest value. So we are not sending the instance or VLAN mapping information. We are just gonna send the digest. We are gonna convert this into the digest value, and then we are gonna sell this information. All good. One more thing that I'm gonna add it over there. So if you compare with, sorry. So spanning tree, if you see one thing, the priority in the PVST protocol and RST protocol, normally what happened out because the RPVST protocol. Normally in this case, what happened? Don't talk about the RPVST because we are in the Cisco right now. So in this picture, what happened? Whatever the priority you have, 32768, that's a default priority. Then after that, you have a VLAN number, right? So for example, if you are doing for the VLAN number 10, then the priority will be 32768 plus VLAN number 10, that will become the 327778, right? So we are adding the VLAN number. But in the MST protocol, what happened? We are not adding the VLAN number. Can you see that? For the MST 0, 32768. For the MST 1, what? 32769. Come on. Sorry, the priority is what? So here we have a instance number. If you see the 2 now, MST2, here we have instance. So not this one like this way. Let me tell you, it's not like that way. What they are doing, that they are just gonna add the 32768 plus instance number. So why it's showing the 1? The reason is that if you remember that we did this configuration, right? This one we did it. That's why it's showing that 1, 2, 3. Because we changed the priority for this guy, right? So if you see the priority, right, of the switch 1, what is there? The priority of the switch 1 is, actually the MST number 1 is what? 0. So it will add the priority is what? Not 0. And then instance number. So instance is what? 1. It will has a 1 now. What I change the priority for the switch 2, for the MST number 2? It's 2, right? So if you see on the switch 2 right now, what happened? The priority is what? Again 0 plus instance number 2. It's going to become the 2 over there. So if you go to the switch 2 right now, so here we are not adding the VLAN number. Here we are adding the instance number. Here we are adding the instance number. So if you see, the priority is 2 now. Same thing for the switch 3, what I did, MST3, right? Priority is what? 0. So priority will be 0 to the switch 3. What is the instance number? 3. It will become the 3. So if you go to the switch 3 right now, so here we are not adding the VLAN number, we are adding the instance number to the priority. So in this case, what happened in the PVST or RPVST protocol, we are adding the priority plus VLAN number. We are adding the priority plus VLAN number. But in the MST case, what happened? We are adding the priority plus instance number. All good?
So the instance is like a group of VLANs, right?
Yeah.
Say one to.
Instance is a group
So,
of aggregator. Instance number
okay, so basically, I mean, if there is a priority plus one instance, that plus instance means 1, right?
right. So I just priorities are all the switches in the priorities what right now. Can you see that?
Uh-huh.
Right. So switch 1 has a what? 0 priority plus switch 1 has an instance number 1, right? 1. Switch 2 has a priority is what? 0. 0 plus what is the instance number of switch 2? 2.
Okay.
And on the switch 3 also priority is what? 0. But what is the instance number? 3. 3 number.
The thing is, did we set up the instance number by ourselves, right?
Yeah. We set it manually. Can you see that? Understood?
And yeah, that's fine. And what about the hash? What is actually hashing? I mean,
Hashing, I'll explain you. Let me do over here. Hash calculator. Non-download, I just like. So hashing is the security term, right? When I'm going to teach you, like, IPsec, then you will see that. Then the CCI .IT is listening. So take example, I just put the any name, right? For example, I said the CCI, that's the name, or maybe it's in the law, right? If you see that, I'll just put the law, L is a capital, E is a small, W is a small. Generate the hash. Let's go with the MD5. That's a more global way. So I have a hash value for this guys or this one. For the log, right? If I do the hashing, I got this value, right? Now we have a what? Maybe as the log, as a small L, AW. Same name, but I just change the 1 bit. I just change the 1 digit right now. And now generate the hash. We have a different hash.
right.
So you see the log. What happened? You're saying that this hash. Can you see that? Is the name is same, but meaning had changed. Right? So basically, just for the security perspective, we are not sending these information on the link. On the link, what we are doing that? This is the switch one take example.
So sending the hash values.
Exactly, we are saying the hash value. Switch 2, so 0/0, 0/0. So we have these are the instance. So what we are going to do that they will convert these are the any hash value, maybe the 81223. So I will send the hash value for this, because if I'm going to send this information in the BPDU packet, right? So I just created the normal instance, right? 1, 2, 3. But take example, if you have 100 plus instance, then 200 plus instance, then how many information I can put in? How many information I can put in the like a packet? It will increase the load on the packet size, right?
Okay.
Right. So normally, if you see the packet size is what? If you go to the Wireshark, just remove that. Sorry. So if you the size of packet is what? 155, 151, 155, 151, something like that. But if I'm going to put the lots of all the instance without the hashing, these are the hash value we have, right? The instance hash. But if I'm not going to put the hash, if I'm going to put all the instance mapping, then what happened? Can you see that? this will be this will be the longer page. And if this will become the longer page, if you have if there will be a more data, there will be a more what size of the packet.
So
Understood?
basically, I mean, say about 100 VLANs, for example. So we can
Not
just
100 instance, 100 instance. Because your
sorry,
VLAN,
100.
eventually your VLAN is gonna map with this instance, right?
Yeah, yeah. And from instance, we can map into the hash value.
Right. So we are converting with the hash.
Okay,
Understood?
but no, that's okay. But let's say if there's 100 instance, how will you map it? For example, I mean, obviously, there's a one instance we just say just you like a one instance and you hash it. There's a more than one instances. So how would you map the whole of them together in one part?
Okay, let me explain. So all this, if you see the span MST configuration, I did it over there. So I jumped
Yeah,
into
yeah,
this box. So
yeah,
for all this box, you will have a one hash.
yeah. That's what I'm saying. So for all these,
Hash, I have one hash for this guy. Single value.
that's fine. Yeah, but how did you just map it like into the online hash calculator?
Oh, how these things are doing in the background? They are using the MD5 algorithm.
Okay, no. What I'm saying is, so you just done the calculator of the hash value to put the hash value.
Okay.
Okay, so for 3 instances, I want to know that. So together, if you want to get the hash value for these 3 instances, how can you
Okay.
do that? How can you do that?
Okay. Your
Obviously,
question is that how this hash is coming?
no. I understand. You got it through the hash calculator. Okay,
No, no,
fine.
no, 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 no. 1 minute, 1 minute. I did this. Oh, hold on. I think so. You're getting wrongly. Hold on, 1 minute. I'll explain it. This has calculator that I showed you, right? I just
Yeah,
where is that?
yeah.
This has calculator that I showed you, right? This is I just show you the how the hashing is working.
Okay,
Okay, I just show you the hashing is working. MST is not using this hash calculator. You got
okay.
the point? I just explain you what is hash.
I see.
Understood? MST is not gonna work this online hash calculator. They are gonna use the MD5 algorithm. So if you see that we have multiple algorithms we have, right, to generate the hash values, right? So we are using one of the algorithms, one of the MD5. Okay, and based
Okay.
on that, MST is converting this thing. So they are not using the online calculator. They are doing the internal process.
Okay, so we don't add or configure anything, it will be done automatically.
No, nothing. We don't need to configure anything, right? So if you see, even if you're on the switch side, you can see that I'll show you the hash value on the switch as well. 1 minute. Spank tree, MST, so spank tree, MST configuration, and hash, no, master digest, or the can digest. So you can see that we have a hash.
Okay,
So all this instance name, we have division number, all instance config, all for this, we have a hash value for this guy. So I just explain the same way. So for all this guy, we have a hash. So you don't need to do this thing. All these things is happening in the background. Okay, this is
I
done by
see.
the MST protocol. The online, not
Oh,
online calculator. This I just gave the example, nothing else.
great. That's fine. And last thing, sorry,
No
about
issue.
the revision number.
Okay.
So,
Okay, let
will
me
you
explain you
please?
the revision number. So
Ex-
remember the BTP revision number we have
Mm,
in the BTP revision. This is the dynamic process, right?
yeah, that's right. Yeah.
Dynamics means if I get the VLAN number 10, so default is what? 0. If I get the VLAN number 10, then what happens? 0 plus 1. If I say the VLAN number 20, then what happens? 0 plus 1 plus 1. If I get the VLAN number 30, then what? 2 plus 1. If I get the VLAN number 40, then what happens? 3 plus 1. Right? Every time what happens, it will add the 1 values, right?
So
This is the
this is a
dynamic
revision.
approach. We are not
Mm,
adding this CR number. Automatically done by the BTP protocol. But this CR, this revision number we have, right? It's done by me. The default is what? The default is 0, right? If I'm doing, it's not mandatory to give this command again. It's optional to give it, right? So that another network engineer will get to know that, okay, someone did the modification in this database. If someone has did the modification in this database, your hash value will be changed. I just gave you the example. If I just change the one bit, one digit, my hash is completely changed, right? Same thing over here. So take example in future, what happened? Someone came and said, hey, you know, one thing in the instance number 3, I need to add the another VLANs over there as the 100 VLAN. Okay, you are the Nazi, right? You change this guy. You change the VLAN data, you change the MST configuration. How do I know that someone had changed it? Because I cannot remember the hash value, right?
I see.
So what is the job role? Your job role is what? You need to change this revision number with the 2. So previously it was 1. Now when I say that okay, the revision number is 2, now I have to check the data. Okay, you change this the VLAN number 100 over there. So this revision number is manually added by the network engineer so that the other network engineer will get to know that okay, there is some changes happen. Understood?
Sorry. Got it. Thank you so much.
Most welcome. Any other one has any questions, guys?
Little bit hard question topic.
No, it's not. See, I'll tell you, it's not a little bit hard topic. I'll take a very easy way. I'm telling you, very easy way. I'll take it. Normally in the CCI lab, CCI classes, I take the RPVST protocol as a 3 hours of the batches. MST, I took the 5 hours of the batches. And took it in a very easy way. I'm telling you, very easy way I take it. So
That's all. Yes.
okay, but still, if you want to learn in the very detailed way, I love to teach you guys. But again, this not makes sense, right? Because you have to go each and every flag. Once you become the like a familiar with these protocols, and in future, if you have any doubts, comes to me, I'll help you that one.
No problem. So we have to do the lab of this one, right?
Yeah, man, you have to do this in the notepad that you have. You can take a sniff if you want.
I mean,
Yeah, tell me.
Just take the picture.
Yeah, that's fine. You can take the picture, or I can say this notepad in the if you want in the WhatsApp group, or maybe I'll send you in the WhatsApp. It's fine. Or anything, I'll send you in the chat as well. Or let me do one thing. I'll upload in the what we drive.
Yeah, I think that's a
Download from
good
there.
idea.
Oh, okay.
Yeah, that's good.
Okay, we will love that.
Yeah, that will be good idea, right? So I'll just say that MST. Oh, I already have one MST. MST CC. Okay, so I'll catch you tomorrow, guys. Okay, I have one announcement, right?